Thanks. We're doing questions on cards, so if you need an index card, you can look on the tables, but we're sticking... We'll pick it up from you. We want to stay on our timeline, so we're going to move on. Ma'am, please, we're going to move on to our next set of speakers. And so thank you again,
Thanks
Professor
for having
Edwards.
me. Appreciate it.
And I'm going to introduce Mark Templeton. He's also from the University of Chicago Abrams Environmental Law Clinic, and he'll be moderating this next panel.
Thank you, Julie. So this next panel is on the interrelationships between water protection and other environmental, public health, and social justice issues. We have with us Ellen Wells, Beth Gingrich, and Reverend Whitaker. Dr. Wells is an assistant professor of environmental and occupational health and the co-director of the occupational and environmental health programs within the School of Health Sciences at Purdue University. The reason I stumbled over that is because she's also an affiliated faculty member with a public health graduate program at Purdue. Her research focuses on increasing our understanding of the neurological and cardiovascular health effects related to metal exposure in humans. And previous projects have focused on health impacts related to lead, manganese, and mercury. Beth Gingrich of Valparaiso University has the Lewis and Mary Wargol Chair in Christian Business Ethics and is a professor of international trade and business law at the College of Business. She's been a member of the faculty since 2001 and serves as its editor-in-chief of the college's Journal of Values-Based Leadership. Our third panelist is Reverend Whitaker of Faith CDC. He's a senior pastor of the Progressive Family Community Church of Gary and president and chief executive officer of Families Anchored in Total Harmony. Reverend Curtis is a certified commercial farmer and certified public accountant. His primary activity is to provide leadership and oversight of the programs of Faith CDC, of which Faith Farms and Orchard, a USDA certified farm, is one such program. Faith Farms and Orchard's mission is to equip urban growers of all ages with the tools needed to become certified growers and to assist in providing access to fresh produce in Gary, Indiana. Obviously, this just summarizes the tip of their experiences and expertise, and I look forward to hearing from them. Again, we will take questions on cards that I will take common themes, just given the kind of limited time that we have, and then pose those questions to our panelists. So at this point, I will turn it over to Professor Wells.
All right, good morning, everyone. All right, so I wish I could tell you that I have a lot of good news to share with you this morning, but there is some good news, but there's also unfortunate news because I am going to talk about lead, which is a recognized neurological toxin. And the way I've framed my talk today is to talk about what we've known about lead over time, because our understanding of lead over time has changed, and I think it says a lot about what we know in terms of regulating lead, not only lead, but other chemicals, and what we can do as scientists and chemists and engineers when we measure these compounds too. So without further ado, so lead is a heavy metal. It's abbreviated as Pb in the atomic, that's its atomic symbol. It's an element relatively abundant, soft, dense, and stable. So in short, lead is easy to get, it's inexpensive, it's really easy to work with, and as a result, it has been used extensively in industry, right? Because it's soft, it doesn't really change when you put it in conditions. So it's a great metal to have if you want to make things. And that's one of the reasons we have such a problem with lead is because we've used it so much, it's gotten everywhere. Okay, so this is just an example of the annual production of lead over time. So I wanted to point this out in that we've been using lead a very, very long time. The Romans were the first to really use lead extensively. they used it in making pipes. They used pipes for aqueducts in ancient Roman times. And so they had lead pipes as well. They used it in coinage. And these are examples of ancient pottery that wine was stored in. And one of the more interesting things about Roman culture is that they used wine, they added lead to wine to make the wine sweeter. So this was a pretty common practice back then. And when you add lead to wine to make it sweeter, obviously you're going to get a very high dose of lead. So it's fairly well established that a lot of people in the Roman Empire had pretty high exposures to lead. And they had an idea back then that exposure to lead resulted in neurological problems. Right? So we knew back from the Roman Empire that lead is a toxin. Okay. Since then, we've used it everywhere, like I said. This is a brief list. I could probably think of about twice as many things to add to the list of places that lead has been or is being used. And I emphasized on the slides the top ones in terms of quantity that we know about that have been a problem. We used lead in gasoline for decades in this country. We used lead in paint for decades in this country. The lead that has been used in gasoline and paint is still in our environments today and is contributing to a lot of lead poisoning. We're talking about water extensively today. So a lot of the lead in drinking water comes from its use in pipes and also solder. So not the pipe itself, but the connections between pipes when you seal them together. And then many other places as well. Okay, so this is a relatively old chart. And I know you can't read the fine print, but I have it here to demonstrate that we have also understand that lead causes a lot of health effects, and we've understood that for a very, very long time. And so this is a brief, there's a lot of words on here, but it is still brief, summary of some of the health effects that have been associated with lead exposure. And they've noted it in terms of concentration on the little tube here. So it starts at 10 micrograms per deciliter and goes up to 150. And if you get all the way up to 150 or higher, you're looking at potentially dying from acute lead exposure. Right? And then you see less severe symptoms as you go down there, but there are still symptoms. And so one of the things I want to point out on this chart that was developed in the late 1990s, initially, I think, is that if you look under children, you see the bottom line of 10 on the chart, and it shows that developmental toxicity, we see all these effects on children's neurological development at exposure levels less than 10 micrograms per deciliter. At the time, 10 micrograms per deciliter was the action level for lead. So it was only if you got over that, that lead was a problem. Okay, so to give a little more context to that graph I showed you earlier, one of the reasons why this graph goes up so high is that if you go back historically, we can document that on average, everyone in the US had much higher blood lead levels than they do today. So this is a chart put together with data from a national survey, well, more than one national survey, and it's showing that on average, blood lead levels dropped dramatically over time. So in 1976, average blood lead was closer to 16 micrograms per deciliter. And then over time, it fell. And this coincides, as you can see, very closely with the decline of the amount of lead we're using in gasoline. So one of the things I want to point out from this slide is that when we took lead out of gasoline, it had a dramatic effect on how much lead we were exposed to. So we're talking about a lot of depressing things, but I like to look at this graph as an example of when we do something about problems that we know about, we can see change. And also, if you remember that everybody was above 16, on average, the average person walking around in the United States in 1976 had a blood lead higher than that 10 micrograms per deciliter value. So not too long ago in the United States, if you think about it, most of the country would have been considered to be lead poisoned. All right, so these are old data. I'm going to get a little bit into showing you some newer data. So as we got a little bit closer into the 2010s, there was a lot more interest in understanding, are what we think are safe levels of lead good enough, right? Because here I showed you that we had some evidence that there were effects underneath 10 micrograms per deciliter. So there's a big push in a lot of places to do research to show whether or not people with lower concentrations of lead that we're seeing now since lead came out of gasoline, is that effective in removing all the health effects we know from lead. Around this time, I was a graduate student working on my dissertation, and I got some initial data from a study. We were using cord blood data, and I measured a lot of metals in it. And I showed the data to my committee. They looked at me and they said, "You probably shouldn't look at lead in your dissertation." Because the levels I had that we found were pretty low. They were on average around 1.5 micrograms per deciliter of lead. Okay? So my committee was not doing this because they didn't believe that lead was a problem. They knew that they would all agree that lead is a big problem, but they wanted me to graduate. And they thought that I wouldn't be able to see any health effects if I looked at a population with lead levels that low. It turns out they were wrong. We did see significant effects in my dissertation for a population that had, on average, lead levels closer to 1 microgram per deciliter. And I wasn't the only one by any stretch of the imagination. This is a summary from a national toxicology program monograph. It's called Health Effects of Low-Level Lead. And so what they did with this was published in 2012. And what they did was survey the entirety of the literature available at the time to see how much evidence do we have that there are health effects of lead lower than 10 micrograms per deciliter. And you can see the summary here. The short answer is there's a lot. We can see that there are quite a lot of health effects that have been documented in communities when you're looking at concentrations, in some cases less than 10, in other cases less than 5. Right? And they run the range from neurological conditions to immune conditions, cardiovascular conditions, renal conditions, and reproductive and developmental health. I could probably, given any organ system in the body, find evidence that lead affects it. Lead is not needed for anything in the body, and it affects every organ system that we know of in a detrimental way. Okay. So the good news from that report was one of the factors that motivated the CDC to lower its blood action level, which they did in 2012. Okay. So again, you can see that I have this slide here to show our interpretation of how much lead exposure is a threat has changed dramatically over time. Back in the 1960s and 1970s, we thought that anything under 60 micrograms per deciliter is probably okay. And now we're down to 5 micrograms per deciliter. And the clincher on that is the CDC and other agencies are very clear that we're setting a guideline at 5, but we don't think that's safe. It's an action level, not a no effect level. Right? Because when they put this together, they had this report, and half of the lines on here are documenting health effects at less than 5 micrograms per deciliter. The problem is a structural one. Often we have limited resources to address lead exposure, and it would probably be, we have few resources to address all the kids who have lead exposures at 5 micrograms per deciliter now. If we took that down further, it would be even more problematic. Okay. So this is a CDC action level. Many places around the country have also adopted the CDC action level for their standards. In Indiana, it's been spotty. Some health departments have adopted the 5 microgram per level standard and some have not. So it depends on where you live in Indiana as to whether they're using the current standard or the old standard in terms of classifying whether or not a child has been exposed to lead high enough to warrant intervention. And so this is a more recent study, and another reason to be concerned about lead, even if we have low exposure to it. So this is a rare case where researchers were able to get together and pool data